Hello, girls. How are you doing? I hope everyone is doing good and staying safe at their homes. Okay. Now let us proceed with the further units of Unit 4th. Sorry, further topics of Unit 4th. In our last video, we have done something called runtime storage administration. It is about the main memory management when we are running the program. When we are running the target code, we require the main memory for it, and we need to manage this main memory, and for that we require this runtime storage administration. The runtime storage administration basically has four has four sections. The first section is the code, where your target code is loaded. Then is your static or the global section, which holds the global values. Then is your stack. So in our last class we have completed with the stack, and I have taught you how we allocate space in the stack. We do it with the use of activation records, which needs to be generated for every procedure in the program. For every function in the program we need activation record, and these activation records form the stack. Now proceeding further with the second part of this runtime storage administration, we have this block structural allocation. Now block structural allocation will be implementing this block structural allocation. Okay, now girls, let me have this. Okay, now here I am with the implementation of block structural language or the allocation. To proceed with this, let us first understand what is meant by storage. See girls, we have two types of storage. One is the local storage and the other one is the non-local storage, right? Now this local storage, or we can say this as the local variables, are handled by the activation records. We have seen that in the last video. Now the next type of storage is a non-local storage, which holds the non-local variables. In order to this non-local variables are handled by the scope information of the variables, like as in what is the scope of variable, is what will be the lifetime of the variable, till how much time the variable is active in the program. Depending on all this information, this non-local variables are available. Now these non-local variables are again further divided into static and dynamic. Static non-local variables whose scope is already decided, like we know that if we are declaring a variable in the start of the program, we know that the scope of this variable will be till the end of the program, right? That is a global variable. Or if we are declaring a variable inside a block, we know that the scope of this variable will be till the end of this block, right? So the scope of the variable is static over here. The other type of scope is a dynamic, where we don't tend to decide it before only, like till when the variable is going to work. Like it happens when we are working with the programs, in a more professional scenario, we tend to make changes in the programs, and hence the scope of the variables also changes. So that is about the dynamic scope of the variables. Fine. So now the static storage of the variables is also known as block structure storage. And because it's static means the size is final, like we cannot change the size. And I have said you that when I have explained you about stack, I have said you that stack is having static size, like stack, whatever things are having the size as static, whoever is having its size as static is managed by the stack. And hence the block structure storage is again managed by the stack, because it doesn't grow much. Whereas the dynamic scope variables whose scope tend to change is managed by heap, which I'll be saying you in the next video. As for now, let us proceed with the block structure storage. Fine, girls? Okay. Now, uh, in before proceeding further, let us have a quick look on what is meant by local data and what is meant by non-local data. I know everyone might be aware of this, but a quick revision is required. So, see over here, girls, code, in this code, that is under this local data, a is said to be a local variable and it is local to the function a. So a is local to a. Whereas over here you see we have another function called test, and under this test we have two variables a, b. Then again I have a different block where I have the variables xy. Moving further, I have another block where I have variable cd. Now all these variables are local to test. All of the six variables are considered to be local to the test function, because the body of test is starting from here and ending here. However, xy is not local to cd, because xy belongs to a different block and cd belongs to a different block. Similarly, cd is not local to xy for the same condition. Okay, so I hope the local and non-local data is clear to every one of you. Now let us move to the next thing. That is, as I said you, we have started this topic called block thing. So I have said you that in order to allocate the space for the blocks, we have this static type of data, that is static scope rules. So under that I have this program, this example for you all. See over here again I have the same function test, and in this test function I have pq. Okay, so this pq is local. Under pq I have another variable p, and after p I have another block with a variable r. Then all these blocks get ended up over here, and then in another block I have different set of variables q, s, t. I hope everyone knows that. Then when I have p and inside another block if I have a p, then this p is different from this p. This p belongs to this block, whereas this p belongs to the upper block, right? So now, okay, so in order to know the static scope rules and how they are allocated in the stack, as I said you, for this variables need a static approach. These variables are static in its approach. So I'm sorry. Yeah, I was saying you that how different blocks of variables, the variables available in different blocks are allocated to the stack. We were talking about that. So in order to understand that thing, in how this block variables function, how this block variables are allocated in the stack, we need to first identify the blocks in this program. So over here, this is my first block, that is B1, starting from here, ending here. Then I have another block which is B2, and it's starting from here, ending here. Then I have a third block which is holding the variable r, starting from here and ending here. Then I also have another block B4, that is QST, holding the variables QST. Now girls, how these block variables are assigned in the stack, let us see this. Here I have a stack, and in this stack, if you observe, the stack is first filled with the things which comes first in the program. Like, so who is coming in the first? It's P, and then it's Q. So P belongs to B1, and then Q belongs to again to B1. Then moving further, I have a variable P which now belongs to B2. This P and this P is completely different, girls. So see that you okay. So this P and this P is completely different. Now this P belongs to B2, and then after P I have another variable R which belongs to B3. Now when I work in this, what happens is, firstly the R gets executed, that it is the value of R gets allocated, and when the value of R get allocated, it is deleted from the stack, it is emptied from the stack. Then the value of P gets allocated, and once it is allocated, the stack is again empty. Now we have another set of variables, that is Q, S and T, and this Q, S and T belongs to the block B4, which is inside the block B1. So in order to approach QST of B4, we need to have the PQ variables of B1. I hope I'm clear, girls. You can rewind the video and listen to it once again. What I'm saying here is, in order to approach R, I need to approach first P of B2, and in order to approach P of B2, I need to approach PQ of B1, which I have explained you already. Now moving to the downward thing of the program, I have three variables QST. Now in order to use this variables QST which belongs to B4, I can go to QST only through the variables PQ belonging to P1. Hence this variables P and Q the variables P and Q of B1 are not deleted, and are further used to approach Q of B4, S of B4 and T of B4. Once we are allocating the space, we are allocating the value to T, S, Q, they get deleted eventually. You can see through this diagram. Clear, girls? So now moving further, I hope everything is clear to you people. See what we have done until now. I am showing you how the block structural allocation takes place. Block structural allocation is part of the static rule variables, like the variables which are non-local but whose scope is static. We know till when those non-local variables will come into play in the program. Such variables are divided into different blocks, and how we allocate the space and values to these variables we are studying in this class. Until now we have studied that, and I have shown you through this example. Okay, I also have another example which can give you a clear idea of this block allocation. See over here, girls. See over here, I have this program. In this program, I have a variable total, and if you observe, total doesn't belong to any of the function, so total is the global variable. Then I have another function square who is having the variable as x. Then I have a function called square of sum which is having the variables x and y. Then I have my main function, and inside this main function I have the variables a, b. Now let us go into depth of this program. As you know that the program starts with main, and when the program execution starts, my stack is active. What does it do when this program is getting executed? My main memory comes into play and all the local things are loaded in the stack. Firstly, the firstly what happens, the target code is loaded in the code section. The global variables or the static variables are loaded in this global section. See, in our program I have a global variable as total, and hence it is loaded over here. Then my program execution starts with main. So what happens, this main gets loaded in the stack along with its local variables. What are its local variables? It's a and b. Fine. Now a and b is loaded. Then what I'm doing, what is happening in the program? In the program I'm calling square of sum function, and when I'm calling it I'm also sending the values a, b along with it. So what happens, my control comes from square of function, from here, from main function it comes to this function definition of square of sum. So what is happening over here in square of sum? In order to hold the values of a, b, I have x and y declared, and inside it square of sum is again doing what? It is calling the square function. So what happens, my control from square of functions goes to the square of sum goes to the square function. Fine. So now I'm over here. So what is happening, when square has been called, what value I have been sent with? I have been sent with the value of x plus y. So 4 plus 8 is 12. 12 has been sent to square, and that 12 is loaded in x. Now the square function is multiplying x into x and returning where? So it's returning to the calling function. Who has called square? It has been called, this has been called by square of sum. Okay girls, eventually also see how it is working inside the stack. See, firstly the main is loaded in the stack along with its local variables. Then the main function has called SOS, that is square of sum, and we have loaded this function along with its variables x, y and z. Then the SOS function, the square of sum function, has called square function. I'm using just short forms of it, but the complete name occurs in the stack, but I'm using the short form. So the square function is called and its variable x is loaded. Now the square function is at the top of the stack. So who gets executed first? Stack follows last in, first out. So who came last? It's the square. So this square gets executed first. So what is happening in the square? It is multiplying the value of x into x, right? So that value is the value. Now the answer is then returned to SOS. SOS, what it will be doing? It will be then assigning the value which came from square function to z, and then that z is returned to main function. So for this way the stack is working. I hope this is clear to everyone. Right. Now, girls, what's the case with the stack is, as I am keep on saying you, that stack is all about the static variables whose size is already, given to us, whose size is static. So it is said because the size of the stack is already static. Like, we don't tend to decide what is the size of the stack, it is decided by the operating system. For example, this stack is having, for example, let the stack have a memory of 1 MB. This is the whole explanation which I have. This is the whole thing, the return and the calling thing which I have explained you already. So coming over here, so now the stack, for example, not for example, like what I was saying you that the size of the stack is already defined by the operating system. So for over here, the size of my stack is 1 MB. So now if I am like keep on loading in the program, like I have loaded A, I have loaded B, I have loaded C, I have loaded D, and in this way if I keep on loading the functions along with the variables, it might happen that the size of stack runs off. So in this case, we are with the situation called stack overflow, which means our stack will be crashed. Like, if we go beyond the capacity of the size of the stack, then our stack is to be crashed. This is the limitation of using the stack. So it means that we cannot decrease or increase the size of the stack dynamically. Similarly, there is also another limitation of using stack, and that is the scope of variables. The scope of the variables, like if a variable is local or if a variable is global, that scope doesn't change when it is already brought in the stack. So we cannot change it. See, girls, when my target code is achieved, that target code is loaded in the code section, and all the variables, the local variables, the functions are loaded in the stack. So once my running of the program start, you all are aware of this. Once I run the program, I cannot change the scope of the variable. The reason is because the stack doesn't allow you to do that. That is its limitation. And then in the stack, because the size of the stack is fixed, we cannot have a variable length array in the stack. Variable length array, whose size keeps on changing, where we don't mention the size of the array. So for such arrays, we cannot use the stack because the size of the stack is fixed and it cannot be changed dynamically. Clear, girls? Okay, let us now move further. Okay, what I'll be doing is, let us now stop in this video. Let us have this much is enough. So what I have taught you, I have taught you about runtime storage. Runtime storage is having four sections: code, static, global, stack, and heap. We have done until now what we have done. We have done about the stack allocations. So the stack allocations is for two purposes. One is for the local data and the other one is for the non-local data. But the non-local data, what is the prerequisite for that non-local data to work in stack? It should have a static size. So all the non-local data who is having the static size works in the stack, like the space is allocated for them in the stacked, and thus I have shown you the same thing over here along with the limitations of the stack. I hope everyone understood it. If you have any doubt, you can ask me.